Hello, Harsh. Hello. Harsh, your mic is not okay today. Okay, fine, fine. Yeah. Okay, okay. My voice is okay now? Okay. So in the last class, we have discussed this uh, when the object is beyond the 2f1, the image is between f2 and 2f2, and the image is real and inverted, formed between f2 and 2f2. Already told you, real and inverted smaller than the object. And after that, we discussed when you place the object at 2f1, then the image is also formed at 2f2. But this time the size of the image and size of the object is same. And also the image is real and inverted. Another case, when the object is between 2f1 and f1, then the image will be beyond 2f1, 2f2, beyond 2f2. And the size of the image is greater than the size of the object. Another case, when you are placing the object at the focus, then the image will form at infinity, because these rays will meet at infinity and image will be real and inverted, larger than the, very, very larger than the object. Now we will discuss the another case. Okay. So we'll discuss the case number 5th, I think. Case number 6th, for 5th. F1, 4th case.
Hello, sir, can you hear me?
Yeah, I can hear you.
So this case number 5th.
Case number 5th, just a minute. 1, 2.
I mean, it's 4th. 5th. Yeah, it's
This
5th.
this is 4th now. So I think we have missed one case. If I will do, this is a focus now. After the focus, we have placed. First, we place the object here. Then we place the object here. Then we place the object here. Then we place the object at focus. So it should be. This should be 1, and it should be 2. It should be 3. Should be 4. Where is the? Okay. Fine. It is 4. Now we will discuss case number 5th. Case number 5th. Case number 5th. And this case number 5th is special case. Case number 5th is the special case. Okay. So here now, in this case, we will take a lens. Suppose this I am taking convex lens. Convex lens I am taking, and okay. So this is f2. This is to f2, f1 and all that. Now we will place the object. Earlier we placed the object at F1. Now we will place the
Yes, sir.
object between this is the optical center. This is the optical center, and we will place the object between the lens, or you can say between the optical center and the focus. So we will place the object somewhere here. Somewhere here the object will place. So this is the object, and now we will draw the ray diagram for this object. The images will be like this.
Yes,
First
sir.
ray is parallel to the principal axis, and it will pass from the focus like this. It will pass from the focus like this. Another ray from this object, will pass from the optical center and will pass straight. Passing from the optical center and will pass straight. So now you can see both the refracted rays are diverging in nature. These diffracted rays are diverging in nature, and these are diverging
Yes, sir.
in nature. So these rays will never meet in reality. So these rays will never meet in reality. So what you have, so there will be no image. Means if the rays will never meet, then we will get no image. But for the
Yes.
image formation, we will produce these rays in the backward direction and we will get the image. Will produce these diverging rays in the backward direction. We have done this thing so many times. Okay, so we will just produce these rays in the backward direction. So here somewhere here you will get the image, and I am showing these rays from the dotted line like this, so that these rays are just appearing to meet. So now you can say these rays are just appearing to meet, or these rays are just meeting when you are producing these rays in the backward direction. So here these rays are meeting and the image will be formed at this point like this. This will be the image. Now this time, can you tell me this image will be real or virtual?
Sir, it will be real, right?
No, it will be virtual. Because rays are not actually meeting. These rays are not actually meeting. These rays
Sir, but
are
in
just.
oh yeah, it's on the left side because in
No, it
case
is.
4 there was infinity and then it was real and what.
Yeah. So image is number one. Where the image is formed, same size, same side on the object. So object is
Same side
on
of
the
the
left side.
yes,
But
between
image
two
is
F1 and F1.
yeah. No. This is not necessary. Means the image can be anywhere. Okay.
Okay.
This is the case where the image is between F1 and 2F1, but all the time it is not necessary that the image will be between F1 and 2F1. It
Okay,
can be
sir.
beyond F1 also. Okay, it can be beyond F1. But the main thing here, the image is virtual and image is forming on the same side as object. So object is on the left side, image is also on the left side. Okay. So image is also image is on same side as object. Can you tell me this image is real or virtual?
So it is virtual.
It is virtual because rays are just appearing
Not
to
yeah.
meet here.
They're not
Not meeting really, not meeting in reality. Okay, so you can say virtual and erect. Virtual and erect image. You will get. Third point. Size of the image. See the size of the object and size of the image. Size of the image is greater than the size of the object.
Size of the object, yes.
Yeah. You can say magnified. Magnified means larger than the object. Now last case we have case number 5th, I think. Sixth case number 6. Case number 6 means when the object will be placed at the infinity. When the object will be placed at infinity. Okay. So object at infinity means, and I told you many times that when the object is at infinity, from that object, rays are always parallel. And parallel rays meet at focus. So object at infinity means rays are parallel from that object, and parallel
Yes,
rays
sir.
always meet at infinity. So parallel rays always meet at focus. So there is a relationship between the focus and the infinity. Means whenever the object is at infinity, image will form at focus, and whenever the object is at focus, image will form at infinity.
Infinity.
So these are parallel rays. These are parallel rays. So now write down fast.
Done, sir. Done, sir.
Okay.
Sir,
So yeah,
so when are we going to finish the portion?
this part.
No,
This
the portion, the whole physics thing.
yeah, I am thinking about it, means what we should do for that, because we have a limited time and we have a limited classes. So either I have to take extra classes or I'm thinking about that. Okay.
Yes,
So
sir.
means is your date sheet released now?
For what? For
Date
boards?
sheet. Yes.
For boards, yeah, it's on 24th Feb, first exam.
24 Feb, na?
Yeah.
Okay. So maybe this month we can finish this. And are there any pre-boards
Yes,
of
sir.
you? Date? What is
First
the date?
Feb.
First Feb. Okay, so I think till Feb means before Feb, we have to finish the syllabus.
Yes, sir.
Okay. And if I will call you means for the extra class, so please cooperate. Okay.
Yes, sir.
Otherwise, we
Yes,
from
sir.
both the side, means from my side also, from your side also, from the both side we have to. Okay. Then we can finish the syllabus properly. Okay. And
Yes.
that is fine. For me also, it is a big challenge this time. Actually, last 2 days from last 2 days, I was not taking the classes because I was
Okay.
suffering from fever and I was
Oh,
hospitalized. So
oh,
that is
sir.
why
Sir, how are you now?
now I'm fine. So there is a delay due to that also. But these
Oh,
are the natural phenomena. We cannot control it, but we can just control our actions. Means what I want to say that, so now we have to take, we should be ready for the extra classes. Okay. And there is a portion left, wave optics, and after that modern physics, and
yes.
after that the last is the electronics and that communication system, you can say. Those
Yes,
things are
sir.
left. Yeah. So okay. This optics was the bigger part as compared to the modern, and communication system is, I think, smaller than the optics. Okay, by the way, let's see. Image formation by convex lens. Now we'll discuss the image formation by the concave lens. Okay.
Yes, sir.
Just a minute. So image formation by the concave lens. So this is the concave lens. Okay.
Yes, sir.
This is the principal axis, and this is the axis. You can say just a line I have just drawn. Here is the optical center. Here is the optical center. Now we'll discuss the rules for the image formation by the concave lens. Rules for the image formation by the concave lens. So first rule is this. Means if a ray of light is passing through the optical center, if a ray of light is passing through the optical center, it will pass straight. If a ray of light is passing through the optical center, it will pass straight. Okay. Number second, if a ray of light is parallel to the principal axis, the ray of light is parallel to the principal axis like this, parallel to the principal axis, and it will get diverged. And when you will produce this diverging rays in the backward direction, when you will produce the diverging rays in the backward direction, it will meet at the focus. It will meet at the focus. Okay. Number third. If a ray of light is going toward the focus, this is F1, and if a ray of light is going towards the focus like this, after passing through the lens, it will become parallel. Okay, if a ray of light is passing through the going towards the focus, it will become parallel to the principal axis. Okay, so these are the three rules for the image formation. Basically, we will use first two rules. Okay. So please write down.
Yes, sir. You can scroll down.
Okay.
Done, sir.
we will see the image formation by the, this is not the image formation, okay, this was the rules for the image formation by the concave lens, rules for the image formation. Now we will discuss the image formation by the concave lens. Hello, Harsh.
Yes, sir.
Am I audible?
Yes, sir. Yes.
Okay. So image formation by the concave lens. So first, the object will be placed anywhere between the lens and the infinity.
Yes,
So we
sir.
place the object between the lens and the infinity. Okay. So suppose I am placing the object here. This is the object, and this object is placed here. And from this object, we'll draw the ray diagram. From this object, the rays, first ray is like this. And if the ray is parallel to the principal axis, what happens? It will diverge, and when you will produce that diverged ray, it will meet at focus. Okay, it will meet at focus. It will meet at focus. So here it will meet, I think. Here. Now another ray from the object I am taking is passing from the optical center like this, and it will go straight. It will go straight. So here the image will form. The image will form here. This will be the image. So this image is virtual, and this image is virtual, and this is smaller in size as compared to the object. Okay. And this is forming, this image is forming between here, somewhere here will be F2. Okay. Here will be F2, between F2 and the optical center. So you can say image is number one, formed on the same side, forms on the same side of that object. Number second, virtual and erect. Virtual and erect. Number third, it will be diminished. It will be diminished. Okay. So this is the case number one, when the object at any position except infinity. Object at any position except infinity. Okay, another case number second, when the object is at infinity. So when the object is at infinity, means this is the convex concave lens, and from the infinity, the rays are parallel to the principal axis and parallel to itself also, like this. These will be the rays. So these rays will appear to meet at focus like this. Appear to meet at focus like this. So basically what is happening here, this is a ray of light. After passing from the lens, it is getting diverged, and this diverging rays, when you are producing backward, meeting at this point, and you are getting the image at this point. So here the image is formed. Image is formed here. Image is formed here. So now you can, here also you can say the image is virtual, smaller than the object, point size formed. So image is here, this time it is formed at the focus. Image is formed, number one, at focus.
Focus.
Formed at focus. Formed at focus, number second. It will be virtual and erect. Virtual and erect. And number third, point size. Point size. So see, the image is very, very small as compared to the object. Object is at infinity, that is very large. Right on.
Then so I can scroll down.
First, are you available on Sunday? Means on Sundays you will available.
It's Sundays, yeah.
Sorry.
Then so I can scroll down.
It's fine. Now we'll discuss the lens maker formula. Lens maker formula. So for this, I am taking a convex lens, biconvex lens. Suppose this is a biconvex lens, and around this lens, there is some medium. Okay, suppose that medium has the refractive index nm. Surrounding medium have the refractive index n suffix m, and refractive index of the lens is n suffix l. Okay, n suffix l. Okay, no problem. Principal axis. Okay. Now, for this surface, suppose radius of curvature is r1. For this surface, radius of curvature is r1, and for this surface, the radius of curvature is r2. Okay, so focal length of the lens, focal length of this lens is given by lens maker formula. One upon f is equal to refractive index of the lens divided by the refractive index of the surrounding medium minus 1 upon r1 minus 1 upon r2. 1 upon r1 minus 1 upon r2. So this is the lens maker formula. So for this, the question can be like, sometimes they will give you plano convex lens. So in that case, you have to decide which one you will take r1 and what you will take r1. For example, one lens is there. This is a lens, and this is a biconvex lens, okay? And radius of curvature both side equal to 10 centimeter. And refractive index of the lens, and of the lens means refractive index of the lens is given as 1.5, okay? And lens is kept in air. This lens is kept in air. Now we have to find the focal length of this lens. So for finding the focal length of this lens, we have the lens maker formula. Okay. So suppose if the object is placed here, so the incident light ray will go in this direction. This will be the direction of the incident light. And I told you the direction of the incident light is considered as the positive direction. Okay. Now R1, this is R1. So R1 means in this direction means this will be the R1. If this is the first surface, then this will be the R1. This distance will be the R1 distance. Harsh, are you getting? This is the first surface now.
Yes, sir. Yes.
This is the first surface, so this will be the radius of curvature 1. I told you. Now for this surface, this is the second surface. So for this surface, suppose the radius of curvature can be somewhere here. This is C2. So this will be R2. Okay. Now when you will measure R1, so you will move in this direction. If somewhere here will be the optical center, so you will move in this direction for measuring R1 because this is very thin lens.
Yes, sir.
So you are moving in a positive direction, so R1 will be positive. So R1 you will take as plus 10 centimeter. But R2 you will take minus 10 centimeter. Why? Because you will measure R2 in this direction. Okay. So refractive index of the lens is given as 1.5. Refractive index of the surrounding, what is around surrounding? Air. So refractive index of air is equal to 1. Or you can say refractive index of medium will be
It's
1.
1.33, right?
No. Of air.
Yeah,
that is of
refractive index is 1.33, right?
1.33
water, yeah, that's
for water. That is for water.
the water, sorry.
Refractive index of medium is equal to 1. Now apply the lens maker formula. Lens maker formula is 1 upon f is equal to refractive index of the lens divided by refractive index of the medium minus 1 upon R1 minus 1 upon R2. Now 1 upon f is equal to refractive index of the lens is 1.5. Refractive
Yes.
index of the medium is 1 minus 1 upon R1 means 1 upon R1 is plus 10 minus 1 upon R2 is minus 10. Okay. Now it will be 1 by f is equal to, it will be 1.5 minus 5 1, it will be 0.5 divided by 1 multiplied by, here you will have 1 by 10 plus 1 by 10. So you will have 0.5 multiplied by 2 by 10. 2 by 10. So it will become 2 5s are 10. And it will become 10 again. It will become, this will be cancel out. And it will be 1 by 10. 1 by 10, okay. So focal length will be 10 centimeter.
Yes, sir.
10 centimeter, plus 10 centimeter it will be. So in this way, with the help of the lens maker formula, we can calculate the focal length. Okay, please write down.
So that's NM, right?
It is n suffix m. Suffix means like epsilon 0, na? We write
Yeah.
epsilon then
Got it.
0. N suffix m.
So in the side, can you write what does N suffix mean and NL means so that I can
Okay. Yes, of course. And thanks for
decide
telling me.
the diagram?
Yeah, I'm just writing, okay. NL means the refractive index of lens, okay.
Yes, sir.
NM
Yes.
is the refractive
Refractive
index
index of the surrounding.
of surrounding medium,
Yes.
and R1 you know, R2 also you know.
Yeah.
Already told you. So F is the focal length. First, today I will leave the class early, okay? Because I'm not feeling well.
Oh, yes, sir.
And,
Yes.
and it will take, I think, one more day or 2 more days to recover properly.
Sir, can I take a class tomorrow?
Tomorrow, actually, I already having classes. Yes.
Sir, what about in the morning?
In the morning, at what time you are free?
I'm fine. I have vacation, sir.
You have vacation, so means all the time you are free. Means
I'm not free. I study in the morning, but you can take it. Right?
okay, so tomorrow maybe I will take your class
Like
in the
you can take
morning.
sir, if you're free at 11:30.
11:30 of your time or my time?
No, your time, sir. My time is 9.
11:30. Okay, we can take it 11:30.
Okay, sir. Sir, you can decide, sir. If I get up at 6, you can take it any time.
Okay, I will means when I will decide it, na. So I will share you the link. Means someone will share you the link. You should join that, and we will conduct the class properly.
Yes, sir.
Now your vacations are going on.
Yeah.
Okay, so I think it's a good time to take the extra classes.
Thanks for long.
Yeah. So in the starting also I told you about R1 and R2.
Yeah.
For this surface, this is R1, and for this surface, this is R2. This is R2 for this surface. So you are in Saudi Arabia.
Yes, sir.
So there the weather is cold
It's
or
raining.
warm?
It's raining. Yeah. It's cold.
It's cold. In India
It's
also it is very cold.
Yeah, it's cold because it's raining too much. It's very cold.
But normally it is cold or not?
Yeah, in
Normally.
December it's cold, but it's not that cold. Like
India.
10 degrees. 10 degrees. Fine.
Okay, I think 10 degrees. I think fine temperature.
But now it's dropping too much because of the rain.
Okay.
And I live in a coastal city, so it's
Okay.
more like it's cold here much more.
Okay. The Middle East countries are like warm countries.
Yeah, like the ones which are not related to seas, yeah, they are warm. But Saudi is not that warm. Yeah, in summers it's the maximum it goes to 45, 47.
Okay.
But it's fine. Like we are now fine with that. I've lived there for 10 years, so it's fine for me.
You are comfortable with that.
Yeah.
Okay, I will just inform you for the extra class tomorrow. Okay.
Yes, sir. So you are leaving today early.
Yeah, I'm leaving.
You can scroll down.